Okay, so before continuing, in the last week class, we have learned about the boundary layer, right? So basically, when the flow is coming, and make a contact with the plate, there will be a thin layer growing. Okay, a thin layer growing. Over here, the U will be undisturbed. And in this layer, it is 0.99 U. Right? This one is your leading edge. Okay, so the thing that you have to remember is this one is your potential flow, this one is your boundary layer thickness, the critical Reynolds number is 500,000, you have the leading edge, the condition at which the boundary layer has the edge, 0.99 U, and depending upon your Reynolds number, you can get your delta, you can get your CF, you can get your what else? CF and CFX, right? Whenever you have X, it means local, it means at a particular point. When there is nothing, then it is the overall or the average, right? When I ask you about the power, about the friction force, usually it is about overall. But if I ask you some specific point, you need to use the local. Okay, and you have REX and REL. The only difference is this one is rho phi x over mu, this one is rho phi L over mu. Okay, when I ask you the point at the end, then this one and this one will have the same value. Okay, so that's what we have learned in the previous lecture. Now, let's take a look at some condition that we experience every day. Okay, if you go to here, don't have. If you go to China, they have this kind of uniform, right? All of those is developed built on the fluid mechanics. Okay, the C5 Galaxy also utilize those fluid mechanics knowledge. Similarly with this B2 spirits. This rocket, right? You develop it as just a thin as a needle because you want to slice through the air. Okay. Why don't you make the shape of the rocket as a ball? Okay. Why don't you make it like a heart shape? Right? Or you want to make it as some other shape? Okay. All the shape is developed based on the aerodynamics profile. So you do not do it just arbitrarily, right? This kind of Air Force airplane, right? The Air Force craft, they are developed based on a different philosophy than your aircraft. Okay. Nowadays aircraft you find it like a big, right, fuselage with wing. But those kind of aircraft has kind of a blended wing because the approach is different. On the one hand, they want to bring as much as possible within. The other one because they want to have a better maneuverability and agility. Okay, those aircraft is naturally unstable. Okay, the jet craft or the Air Force jet is designed unstable naturally. Then how they can fly if they are not stable is because they have a lot of computer. to control it, right? They make it unstable such that they can do that easily. Because if your aircraft is stable, like your commercial aircraft, you cannot do that. Okay, you cannot do that with your A380. Okay, if you bring A380 and suddenly you want to do stun, okay, most likely the wing will collapse and you will get bye-bye. Right? But those kind of things they can, because they are developed for agility and maneuverability, not for stability. Okay? So, a phenomenon where the fluid is moving over a stationary body. Let's say you are sitting in front or at the front of the desk fan. Okay, you are sitting there, enjoy the flow coming to you, right? Or you don't have a desk fan, but you still want the air to come to you, so you run. You do running, the air is, you feel like the air is coming to you, while in fact you are coming to the air. Right? So those kind of things, or if you have both, like your car moving in a typhoon, right? You have typhoon coming to you, you do not want to wait, you go to the typhoon. Then you got moving body in a moving air. So all of those is the same. It's called flow over bodies or external flow. This is the naming in fluid mechanics. Industrially, it is called aerodynamics. Okay, fluid mechanics that deal with external flow. Depending upon the shape of your body, you can have a 2D problem. You can have axisymmetric problem, which is also 2D, and you can have a 3D problem. Of course, as much as possible, I would like to have this. If possible, in my life, I just want to have a 2D rather than 3D. Okay, if I cannot have a 2D, at least I can get the axisymmetric 2D. If not, then no choice, you need to go for the 3D. Right? So this is the outcome of our today's class. Hopefully we can finish it. So you will know some phenomena associated with the external flow, such as drag, friction, and pressure drag. Drag reduction and lift.